In this class, I am going to discuss the laws of motion. So, in the previous classes, I have discussed about concepts like acceleration, velocity, but I never discussed about the reason for a body to have acceleration or velocity. In this chapter, we will look into that particular subject. So, here I am going to introduce a concept called force. What is force? Force is a push or pull which produces motion in a body at rest. Okay. What the second point says? Stops or tends to stop a body which is in motion. Very simple. Increases or decreases the magnitude of velocity of a moving body, changes the direction of the moving body, changes the shape of the body. Let's see each point in detail. So I'll give an example. So here I have a trolley. You have a trolley. Okay. I have a person standing here. Now it says, now let us assume the trolley is at rest. That means it is 0 meters per second. That is, the trolley is not in motion. If I want to move the trolley, like if this boy want to move the trolley in the forward direction, what should he do? He should give a push. Okay. If he wants the trolley to move back, what should he do? He should pull the trolley back. So you can see, when I push the trolley, it moves front. When I pull, it comes back. So this action of push or pull, where the body moves from rest, is called as force. Okay. So what it says? Force is a push or pull which produces motion in a body at rest. Here the trolley is at rest. If I want the trolley to move in the forward direction, I give a push. If I want the trolley to come in the backward direction, I pull. Okay. What is the next point? Stops or tends to stop a body which is in motion. Okay. Let us assume a trolley is moving. Let us assume a trolley is moving. Means this boy is pushing the trolley. Let us assume the trolley is going at a speed of velocity of 1 meters per second. So if this boy wants to ensure that the trolley comes to a halt, what should he do? He just pulls it back. He is pushing the trolley. He pulls it back. What happens? The trolley comes to a halt. That means by applying a force, stops or tends to stop a body which is in motion. What is the next point? Increase or decrease the magnitude of velocity of a moving body. Let us assume the same example. Let us assume that trolley is moving at a velocity of 3 meters per second. The trolley is moving at a velocity of 3 meters per second. Now the boy wants to reduce the velocity to 2 meters per second. If he wants to reduce the velocity to 2 meters per second, what should I do? What should he do? He should just pull it back. So what is he doing? He is applying a force in the opposite direction and the trolley is reducing its velocity, or you can call it as speed, anything. If it is, since it is going in the same direction. So if I want to reduce the velocity, what should I do? I should just pull it back. Means the boy will pull it back and it reduces its velocity. Okay. Now, if I want to increase, what should I do? I need to push. If I push more, if this boy pushes more, what happens? The velocity can increase to 4 meters per second or whatever it may be. So you can see, by applying force, more force, I'll be able to increase the velocity of the trolley or decrease the velocity of the trolley. Okay. Now what is this next point? Change the direction of a moving body. Let us assume I have a table. I have a table here. Okay. I have a table. Now a ball is moving in this direction. If I want to change the direction of the ball, what should I do? I need to deflect. I need to apply a force. I need to apply a force so that the ball gets deflected. So it's very simple. When a ball is moving straight, if I want to deflect the ball, what should I do? I need to apply a force. If I want to deflect in this direction, I apply a force in this direction. If I want to deflect in this direction, I apply a force in this direction. Okay, it's very simple. Now what is it? The next point. Changes the shape of a body. It's very simple. Very simple. Let us take, I have a metal cube. If I take a hammer and hit it, what happens? It just compresses, right? After hitting, what happened? It just compresses. It just compresses. I hit a metal cube. Let's take it is aluminium or any cube. When I hit, what happens? It just compresses. So you can see, by applying force, I'll be able to change the shape of a body. The next concept that I'm going to discuss is classification of forces. Let us see what is classification of forces. So here there are two classifications. Forces can be classified into two types. One is contact forces and is non-contact forces. So what is the difference between contact force and non-contact force? It's very simple. Let's take, I have a trolley. If I want this trolley to move, what should I do? I need to push the trolley. Means my hands are coming in contact with the trolley. That means I have to push the trolley. My hands will come in contact with the trolley. I apply the force, the trolley starts to move. So it's very simple. In contact forces, the force is in contact with the object. Now coming to the next example, non-contact forces, what it says, let's take an example of a magnet. I have a magnet, okay, north, south, I have a magnet. I have some pieces of nails, I have some piece of iron nails. Now if I bring the magnet close to the nails, what happens? We all know when I bring magnet close to an iron nails, the nails gets attracted to the magnet. Okay, so I bring the magnet close to the nails. What happens? The nails gets attracted to the magnet. That is the nails gets attracted to the magnet without the magnet coming in contact with the nails. That is the moment I bring the magnet close to the nails just jump towards the magnet and gets attracted to it. So here you can see the magnetic forces are pulling the nails towards the magnet. This is called as non-contact forces. That is, the magnet doesn't directly touch the nails. When it comes nearer, closer to the iron nails, what happens? It just gets attracted. It just jumps, just flies up and gets attracted to the nails. So this is called as non-contact forces. Now we will see frame of reference. Let us discuss frame of reference. So what is frame of reference? Frame of reference refers to the point where an observer observes an activity. So in this case, there are two types of frame of reference. One is inertial frame of reference and one is non-inertial frame of reference. So the basic difference between inertial frame of reference and non-inertial frame of reference is that in this case, this is non-accelerated. This is accelerated frame of reference. I'll explain it in detail. Now let me give an example. I have a car moving at a velocity of 10 meters per second. And I am observing this car standing here. So what is my velocity? It is 0 meters per second. See, I am observing this car and this car is traveling at a velocity of 10 meters per second. Here I am observing the car at this point, standing at this point, that is v is equal to 0 meters per second. Now the point is, this is called as inertial frame of reference because there is no acceleration, because I am standing at rest. There is one more case to it. I am moving, I am running. Let us take, I am walking at a velocity of 1 meters per second, and the car is moving here with the same velocity v is equal to 10 meters per second. So what I would like to tell you is that here I am moving with a velocity of 1 meters per second. No, I am not accelerating. I am moving with a uniform velocity of 1 meters per second. This is also called as inertial frame of reference. Why am I calling both these cases an inertial frame of reference? Because both are not accelerating. I am not accelerating in both the cases. Now coming to this case, let us take an example. I am accelerating, having an acceleration of 1 meters per second square, and I have a car. I am observing a car which is moving at 10 meters per second. Now this is an non-inertial frame of reference because I have an acceleration. So accelerated frame of reference means I am observing a vehicle where I myself am having a acceleration of 1 meters per second square. That is, I am not moving with a uniform velocity. So this is called as non-inertial frame of reference. We need to remember one point, that Newton's laws of motion that I am going to discuss in the coming videos. Newton's laws of motion are applicable to inertial frame of reference, and Newton's laws of motion are not applicable to non-inertial frame of reference. So this is a basic idea I would like to give about inertial frame of reference and non-inertial frame of reference. So here Newton's laws are applicable. Here Newton's laws of motion are non-applicable. Okay. Now we'll go to the next topic.